Hello. So my name's Tom. I work for a company called Icon Solutions. I've kind of been working there for 6 years. I haven't really had any kind of formal MD training, or kind of not really an academic, so please be kind. But I thought this would be kind of a nice kind of way to talk about what we're doing there and some use cases that we're working through this year, which touched on EMF and MPS. And this kind of code here, ISO20022, which is an industry specification for financial institutions. To save saying ISO2022 multiple times, I'm just going to maybe refer to it as the meta model or model. Yeah, let's go. Okay, so what is ISO 2022 and why do we kind of care about this? So it's a very, very kind of important specification and standard that kind of all banks are either implementing or kind of need to implement at the moment. It covers lots of different kind of array of activities, from payments, kind of assets, securities, trades, that sort of thing. There's a registration authority which kind of hosts all the information around it, but ultimately, it's a set of rules that you need to apply for XML messages that are exchanged between financial institutions when an activity occurs. So if I want to pay someone in the audience and do a credit transfer, kind of our banks behind the scenes need to do a message exchange, and this kind of is adhering to this specification, which is certain message choreographies. And you can imagine there's lots of like technical acknowledgements and that sort of thing as well. So there's lots of messages, lots of rules, and this is the kind of the standard specification. And the benefit from banks implementing this is that there's lower cost of kind of development if everyone's speaking the same language and that sort of stuff as well. So typically, when banks look to adopt this specification, they kind of look to the registration authority and they say, what kind of resources do we have on hand to be able to implement these messages? The number one thing that they kind of look at is the XSDs, so the schema definitions. These are fairly standard stuff for defining an XML kind of document. It contains complex types, and you can use this, and depending on the language that you're implementing, you can kind of generate a POJO representation. We're a Java shop, so we did use XJC, and there's kind of obviously other languages as well. In addition to this, there's also kind of an implementation guide, kind of big documents that have been written as well, which support these XSDs. And these contain more information about the business context and the messages and how you use them in different use cases. And they also contain rules and constraints that you wouldn't be able to express in the XSD, or at least not in the version that the registration authority is using. So things like a certain data element must not appear more than kind of once. If it can appear in different places within the document, it kind of has different cross-references and all of that sort of stuff. So all these kind of constraints are listed out, and this is written, as prose. It's not executable, it's not implementable. It's just kind of there. In addition to that, they have kind of an online portal. It's like a data dictionary. You can go in, kind of query certain things, and you can find that as well. So in summary, you have the registration authority, which is providing an online repository, the XSDs, and then these document-based kind of supporting materials. And on the right-hand side, financial institution development teams, they would use these kind of three resources to be able to create executable software and implement these messages as part of their build. And so you would say maybe create Java representations of the message definitions. You would need to manually implement the rules which have been defined in the reports, and you have to consider things like serialization and all of that stuff as well, if you want to use them for API specs. The interesting part really is the fact that those three kind of assets, the repository, the definitions, and the definition reports, are all really kind of projections from a centralized e-repository. So the entire kind of model for ISO 2022 obviously has a meta model, and that's defined in EMF as an e-core model. And the repository itself is like obviously an implementation of that model, which is available there as well. And this is kind of the interesting point, because if we can leverage that model more, then we can get more value and richer software artifacts as well than just depending on these XSDs. So yeah, there's limitations with the XSD approach. Just using these as kind of interface exchanges. Each XSD is self-contained, so you end up with duplicate complex types and all these kind of things that are a bit of a pain if you're an application developer and you have to kind of solve them. And there's kind of companies that have been set up that actually are focused on making this approach easier. They will do kind of the deduplication for you. But also it's difficult to kind of customize the generated code. If you have an XSD and you want to generate a Java Pojo, then you're kind of bound by what you can do in the XJC kind of configuration. And the same is probably true for other languages as well. If you want to generate something and you just generate it from the XSD, you have a limited source, so you have a limited output as well. And obviously you can't generate anything that's just described in the documentation. If you don't have an executable specification, then you can't really do anything with that. So ISO20022 has a meta model. I'm not really going to kind of discuss it in any detail here, but it's a very kind of rich business-oriented model. It has various kind of layers. At the top level, you're talking about business processes and business areas. Then you start talking about, okay, who's involved, what do they need to do? And then finally, kind of at the logical layer, that's where we're looking at the moment, which is, okay, what are the messages needed in order to be able to fulfill this kind of transaction? And the first two layers are kind of, they're not included if you just look at the XSD, if you just look at the documentation. They're kind of hidden within the meta model itself. So the goal that I had over the past year was to be able to try and leverage as much of that as possible and generate software from that as well, not just be focused on the individual messages. So this is probably too small to see, but the main principle is that there's a formal meta model. There's probably about 100 different concepts within that, and you can trace between the different levels in terms of the messages and the business processes and all of that sort of thing, and all of that information is part of the meta model. So for a bit of kind of history, at Icon Solutions, we use MPS. We've been using that for kind of three years now. We use that as a kind of core part of our toolkit. We have a DSL, which allows banks to be able to define payment processing flows. And from that, we generate Java source code, BDD scenarios, diagrams, documentation. And so we've been using this for a while. And so when I kind of saw that, okay, there was a meta model and an e-repository for ISO20022, and we knew that we had kind of capabilities in generating from MPS, you can imagine the conclusion, which is, okay, if we get that information into MPS, then we'll be able to generate lots of nice stuff from there as well. So this is kind of what we're aiming for. So from the registration authority, we're going to take the eCore e-repository. We're going to import that into an MPS implementation of the language. And then from that, we could generate much richer and kind of more varied application code as well. So the steps to do that were, well, first of all, we need to create an ISO20022 MPS language. And so we used there was an open source tool, I think on GitHub. There's a link at the end of the presentation, which allows you to take an eCore file and import it into MPS. It works pretty much like 90%. There's obviously some concepts within eCore which don't really kind of exist within MPS. So I think it automatically has the provision for inverse references. So if you have a kind of a reference from one concept to another, the second concept will also have a link to be able to find all the things that reference it. An MPS doesn't have that. So you find yourself importing the language and then having to go through and clean up some things which you don't need. But in and large, it works very well. And then we had to consider, okay, well, how do we get the data from the eCore kind of repository into MPS as a solution? So in order to do that, I had to generate a Java representation for the meta model from the EMF. And in order to do that, I first had to kind of load up the EMF kind of eCore repository, which sounds straightforward, and it probably is for many people here. But the actual repository itself was a 100 megabyte XMI file because there's so much data in it. And that means that I think Eclipse, by default, when it opens up the repository, it tries to load all of the references. So you actually have to write a custom I think it's a XMI resource factory or something in order to be able to, say, lazily do that later. So that was interesting. So we get that open in EMF, and then from that we can generate a Java representation of the meta model. Everything works out fine. And then we create a Java utility to be able to read the EMF repository file programmatically into the Java representation. And at that point, you've got kind of the model in Java, and that's kind of a nice place for us to be. Then we created a plugin within the MPS language, which allows us to invoke that. So I can go into MPS and I can say, import the ecore file. It will load that into the Java meta model. And from that point, the work is just to create the MPS nodes from the Java meta model. So I kind of encapsulated that in point 5, which was write import framework. That was pretty much most of the work. Once that was done, then we wrote the MPS generators, which generate the Java representation of the model itself, and then you can compare that with what you generated from the XSDs just by reflection. So that was kind of the general process. It's probably a bit easier to see like this. So on the left-hand side, obviously we have kind of the original EMF repository, and this kind of gold arrow is the creation of the MPS equivalent language. That was done effectively automatically with a bit of cleanup. We then also produced the Java meta model, and then we created the importer, which is a combination of red and blue because it's part Java, part MPS. That uses the Java meta model, it reads from the ecore file, and then it creates the nodes within MPS. And once you've got the model in MPS, then it's just normal generators to be able to generate anything that you want. So the import process, and we're kind of doing this for the first time, so this might be kind of obvious to kind of lots of people who've kind of done this sort of model-to-model transformation before. But the key to this for me was understanding that you kind of need to do a traversal twice. So if you're starting with the model on the left-hand side, and that has a few concepts, it's got B2 is a child of A1 and C1 is a child of B2, but C1 also references B1. Then if you try and do everything at once, you've kind of fall into the trap where the nodes that you're referencing may not have been created yet. So what we found was that actually you do a standard kind of, I'm going to create a node starting from J to A1. I'm going to populate the scalar attributes on that concept. Then I'm going to go and I'm going to go into my child, and then it's going to recursively create and add the properties all the way through. So you create the tree in one pass. Once everything's created, start back from the beginning, start back from the beginning, and then you can traverse it again, this time just decorating the references. So that was kind of the approach that we went to. In order for this to happen, so what made this possible within kind of MPS was the fact that obviously, as well as the structure aspect in MPS, you also have a behavior aspect, the ability to add kind of functions and methods mainly to concepts. So for example, on the left-hand side, the root kind of conceptual element in the Java meta model is a model entity. Entity 1, extends that. Entity 2 extends that. Everything extends that. And the equivalent in blue is the MPS kind of model entity as well. And you have the same structure, but we added methods to the model entity MPS concept that allow it to initialize from the Java model, and that meant, okay, I'm a MPS thing, I get initialized from a Java thing, and I'm going to populate the attributes, and I'm going to be able to call my children and try and create those and traverse them as well. And in order to do all this, there's a couple of things that we needed, that you kind of need if anyone's looking to kind of do this. It's useful to maintain a context during the generation that will contain mappings between the origin node and then also the concept that it created, and also the IDs. And And having this context means that the next time that you're doing the traversal through the tree, if you need to find out what the original reference was for the node that you're creating, you can use this as well. So I don't really have time to kind of demo this, but I've got my laptop with me. So if anyone's actually interested at lunch or anything, then feel free to have a look. But this is kind of what we were kind of looking for. So kind of what was the outcome? So we've done all this, it's working, we're kind of using it, we're already kind of seeing the benefits. So the output from this process and the resulting generated code is identical to what would be generated from the XSDs. Apart from now we've optimized it, we've customized it and gone further. It's smaller, richer and kind of more consistent. We've also now been able to generate things which were not in the XSDs. So in the supporting documentation, there's like a list of rules. We're now able to define kind of, interfaces and rule definitions for all of that sort of stuff as well. And we're gaining kind of insights into other areas of the model. And obviously the main benefit from this is now we can just generate the entire model. So previously you had to kind of manually do this for each XSD, whereas now we can get all of the data from ISO20022 and we can generate everything. And the benefit of it being in MPS is we can now use this from some of our other languages as well. So that was kind of the outcome. So what do we kind of learn from this, I guess, is kind of the most important part. So yeah, I kind of mentioned that there's obviously differences between the EMF kind of representation of a model and MPS. So you do kind of find yourself going through the language after the import and maybe updating some enums or kind of removing some redundant references. But there's a very good tool that kind of that does the import as well. We found it simpler to kind of as a Java developer, it's often kind of typical that you want to create your object once and it's immutable, and so you do everything up front. Whereas with this, it was actually simpler to separate the creation of kind of the concept. So you would create the node, populate the attributes, then traverse to the children and go through that, and then finally do the references at the end. So there was kind of a mindset shift in terms of, okay, actually, I'm creating this kind of tree, but as part of the creation, I need to do the traversal as well. It wasn't just a case of create this object once and then kind of add it there. Yeah, so a traversal twice solves a problem of kind of reference nodes, and then maintaining kind of a context map between the source objects, the targets, identifiers, and types enables that kind of lookup as well. And also, I think it's possible that, I'm not sure someone will be able to advise me. I think there's a way that you can use kind of raw E-object proxies to be able to read EMF data without having a Java meta model. But actually, kind of in hindsight, it seems like using a strongly typed Java meta model was much more clearer when you're using it as a middleman to get into MPS. And I think with that, yeah, there's just some links there. So at the top, there's the tool for being able to do the importer. There's a couple of ISO and eCore kind of variations there as well. There's other people who've done similar things where they'll take the eCore but use Java Poet, and other ones that will kind of do things differently as well. But I think that is everything for me. So happy to field any questions.